Question number 5. A biased dice is rolled by 2 people. They win a prize each time they roll a 6. Katie and Dan each roll the dice a number of times and record their results. So here's the table. Katie has rolled it, and she must have rolled it 30 times. I'm going to put that here, because 22 times she won and 8 times she lost. And then Dan, he rolled it, 47 times getting a win and 13 times getting lost. So he must have rolled it 60 times. And actually there are 3 different estimates for winning that I can have. I can have Katie's estimate. Okay, so Katie's estimate of winning is, if she just took her information, her estimate for winning would be 22 out of 30. You could simplify that to 11 out of 15 if you wanted. Dan's estimate, now he did more rolls, didn't he? He did 60 rolls and he got 47 wins. It's 47 out of 60. Okay. Now the other estimate which you could have, which I don't think many people used at all, was if you added up Katie and Dan, because they're rolling the same biased dice, okay, the same dice. So if you took the total estimate of Dan and Katie combined, so I'm going to call this a combined estimate. Okay, then you would have how many wins? Well, 47, 57, 67, 69 wins out of a total of 90, which you could simplify down to 23 out of 30 if you wanted. Okay. So that's my combined estimate. Now, I mean, you just need to write any 2 of those here. So I'm going to put Katie and Dan's because that's what most people did. So, and I'm going to keep it out of the 30 here. Doesn't say to simplify as far as possible. So 22 out of 30 and 47 out of 60. Now, which of the estimates is the better estimate for the probability of winning? Give a reason for your answer. So many people made a mistake here, and the mistake they made was to say that the one with the greater probability of winning was the better estimate, and that's not the case. Just because somebody comes up with an estimate which is more likely to win doesn't make it a better estimate. It might be, a more favorable estimate for a player, but it's not necessarily a better indication of the actual probability. The key thing is, the more rolls you try, the more trials you have, the better your estimate will become in general. Okay, so we want the one with the most trials. So in this case, Dan's estimate is better because it's out of 60 trials, so it's more likely to be more accurate. The combined estimate is even better because that's out of 90 trials. If you've chosen Katie's estimate and Dan's estimate, then the answer is Dan's estimate. Okay, and the reason is that he's had more trials. Okay, so he's completed more trials. So his answer is more likely to be accurate. We know that if you flip the coin just once or twice, once is would give you no real indication as to whether if they're a biased coin, of whether it's give you no good indication. If you flip it twice, it's still no real indication. If you flip it 100 times or 200 times or 1,000 times, you've got a pretty good idea about whether it's biased and how biased that coin would be. It is the key thing is the more trials you attempt, the better your data is.